All right. Now, this is integration, vector integral calculus. We are starting with first ordinary integration of vectors. So if two vector functions f of t and g of t are such that derivative of g of t gives us f of t, then integral of f of t with respect to t will give us g of t plus c, where c is an arbitrary vector constant. Okay. So now, if we do a definite integral, if this is definite integral like this, then the antiderivative substituted by the upper limit minus the antiderivative substituted by lower limit. So this is ordinary integration of vectors, direct integration. Okay. Now next, second part, which is of very great importance to us, is the line integral. We have line integral, surface integral, and volume integral. So first one is the line integral. So consider a continuous vector function f as a function of r, the position vector, which is defined at each point of curve C. In three-dimensional space. Now this limit n tends to infinity, summation of I equal to 0 to n f of Ri dot delta Ri. This limit is called as the tangential line integral. Of f of r along C. And is written as integral of f r dot dr along C, or integral, if r is in terms of t, then you get f of t dot dr by dt times dt. Okay, so this is a line integral. This is a line integral. So now let us look at this. So why is it called a tangential line integral? Because we know that dr represents the tangent, and any function dot another function is projection of one function along the one vector along the other. So it is the projection of f along dr. So therefore, it is the projection of the vector function along its along the path of the curve. So each time there is a tangent there. So f dot dr gives that. So this is the line integral. Now let us take note of important results, corollary results. Very important. When the path of integration, is a closed curve, then the integral is denoted as look at this, integral is denoted as integral with a circle sign like this. It means that it's a closed path integral. It's a closed path integral. Now next, if f of r is f of x comma y comma z times I plus g of x comma y comma z times j plus h of x comma y comma z of k, and dr is I dx plus j dy plus k dz, because r is xi plus yj plus zk, so dr will be dx I cap plus dy j cap plus dz k cap. So now therefore the line integral f dot dr along the path C is integral of, look at the dot product, we get f dx plus g dy plus h dz. Okay, this is the most important common type of line integral. This gives a scalar, but now there are other types of line integral. Two other types of line integrals. This is cross product, which we'll not use so often, and integral vector integration of a scalar field. So these are the other two. Most commonly we use this f dot dr is the most common. Then very important result, theorem. So what is this? If f dot dr is independent of the path C. If f dot dr is independent of the path C, no, the statement is this line integral is independent of the path C if f is a conservative vector field. That is del cross f is 0. For a conservative vector field, the line integral is independent of the path. The line integral is independent of the path. Okay. So this is about line integrals. We will do one or two problems on line integrals. So we will do this. I have given in the exercise. I'll just share that exercise with you. Okay, first one is very, very simple. We'll do this. Okay, so the first one. If f of t is this, find integral f of t dt. So this is very, very simple. The first part, integral antiderivative of f of t dt. So this is antiderivative of 3t square minus t times I plus 2 minus 6t times j minus 4t 40k. Okay, with respect to t. So we get 3t square integral is t cube minus t square by 2 times I plus 2t minus 3t square antiderivative minus 2t square times k. This is the integral, straightforward. Now, the second part, if we have to integrate between limits, so substitute in this. So we get 4 cube minus 4 square upon 2 minus of upper limit minus lower limit. If you do, we get easy solutions. Then 2t, we get 2 into upper limit minus the lower limit. Okay, minus 3 into upper limit square minus lower limit square. Then the last one, minus of 2t square minus 2t square. So this is 64 minus 8, 56. The first term gives 64 minus 8, 56 minus of, let us see this, 8 minus 2, 6. So 56 minus 6 is 50. Let us look at the next one. Now 2 into 2, 4. Now this is 16 minus 4, 12. 16 minus 4 is 12, 12, 3 is 36. Yeah, 36. So this is minus 36 plus 4. That is minus 32. And next one, 16 minus 4, 12 into 2, 24. So this is one example of a very simple line integral. Now let's look at another example. Acceleration I'll omit. Okay, evaluate from, it's not a closed path here. All right. So f dot dr. F is in terms of xyz. So f is in terms of xyz and xyz are in terms of t. So if we substitute in terms of t, so substituting in terms of t, x is t and y is t square. So x square minus 2t square. Then minus 6 into y into z. 6 t power 5. Now next it is 8x z square. Now z square will give us t power 6. Then times x t power 7. So this is f. Now what is dr? dxi plus d by j plus dzk. Now what is f dot dr? F dot dr will be t square. Acha, dr will convert. Dx is dt plus dy is 2t dt plus dz is 3t square dt. So this is f is t square minus t square minus 2t square is minus t square times I plus 6, sorry, minus 6 t power 5 j plus 8 t power 7 k dot dt. I'll take dt outside. I'll get I plus 2tj plus 3t square k dt. So we get, take a dot product of this, we get minus t square minus 6 2 is 12 t power 5 plus 8 3 is 24 t power 9 dt. This is what it is. So therefore, integral f dot dr, so is integral this one minus t square now this is minus 12 t power 6 and this is t power 9, correct? So this is t square minus 12 t power 6 plus 24 t power 9. And this path, this integral path is from t equal to 0 to t equal to 1, because you can cross check. X, Y, Z all vary from 0 to 1. So t will also vary from 0 to 1 in all cases. So this is minus t cube by 3 minus 12 t power 7 by 7 plus 24 t power 10 upon 10 from 0 to 1. So you get minus 1 upon 3 minus 12 upon 7 plus 24 upon 10. So which is 12 upon 5. So this together will give us 35. You divide this. So these are all primes. So 35. We get 7 5s 35 here. 3 5s 15. 12 into 15 is 180. Plus 12 into 21 is 252. So we get 37 upon 105. 37 upon 105. Okay, students, just a second.